Right, so morning everyone. Today we are going to be starting a new unit which is about particles and their behaviour. So today we are going to be looking at what different materials are made up of, and then we are going to try and use the particle model in order to explain about how we can use building blocks, so kind of Lego, in order to represent some different common substances. Our final bit, which is probably the most difficult, is to be able to evaluate the strengths and weaknesses of some different particle models. So first task is pause the video or in actual fact, I will run the video for a minute, and in that time, see how many different materials that you can identify around yourself. So, go. That's halfway. Last 10 seconds. 5, 4, 3, 2, 1. Right, end. Okay, you should have hopefully got in the middle that there are wood, metal, plastic and iron here, but there's also a whole lot of different ones. I'll have a go at this task after I finish recording this PowerPoint. I'll put on show my homework about how many I actually managed to get in the minute. So this is a video about atoms, which is something that we've already spoken to. So it's produced by a company called IBM, and they are able to manipulate atoms at individual scale, and so you can see that in that image there. So what they've done is, using their technology that allows them to manipulate atoms, is that they've produced this short film showing a kind of a cartoon strip, a stop motion animation. So of course the amazing thing about this is that atoms are absolutely tiny. So they're very, very hard to see. You'd never see one with just using your eye, but using very, very powerful microscopes, we're able to visualize them. Okay, so materials are made up of tiny particles, and we've already learned about the fact that these tiny particles can be atoms sometimes, but these particles also can sometimes be molecules where atoms are joined together. So particles are really small, and materials can contain many different particles, and these particles can be joined together, so it can be a compound, or they can just be mixed together, so it's a mixture. Sometimes when we look at a substance, it will contain only one type of particle, and that particle could potentially be a compound. So we can refer to them as being pure substances, but if it's made up of only one type of atom, then we can use that special term elements. So what we have represented here is, in this top corner, the top left corner, where you can see my laser pointer going now, we can see the reaction between sodium and water. So sodium has been thrown onto water, and we can see that there is this explosive reaction. And so we're representing a sodium particle here with this blue atom. Over on the right hand side, we've got, this is a toxic gas called chlorine, and so we can see this person is wearing a gas mask in order to protect them. Chlorine is a horrifically poisonous gas. We use it in very small amounts in swimming pools to keep swimming pools clean because it's very effective at killing things, and it's been used in wars as a way of killing people. So these two substances, when we react them together, must react in a horrifically terrible way, and there's a big vigorous reaction between them. The interesting thing about them is that those two substances have these really dangerous and problematic properties as individual elements, but when they react together, all of us consume this compound every day, because that compound is called sodium chloride, and sodium chloride is of course excellent on our food, and so particularly we're thinking about salt on our chips. So the table salt that we use is sodium chloride. So when particles react together, the behavior that they have that they start off with can be very different to the behavior that we have when they're joined together. Their properties change. And so we can think about this if we think about, if I was to say that we said that chlorine gas is a green gas, actually the particles aren't green. This is just a model to help us to understand it. If we were to look at the atom themselves, they would not possess that green colour. So the properties of substances when they're all together can be quite different, and when we join different particles together, the properties of those particles change from what they are by themselves. So I would like you to have a go at this gap fill on your worksheet now, please. So pause video, have a go at this. So answers wise, all substances are made up of tiny parts called particles. Different substances or different materials contain different particles. For example, a piece of iron contains particles of iron, and a glass of water contains thousands and thousands of water particles. Particles have certain properties when they're all together in a substance, but when they're on their own, they don't have these properties. A gold ring has a yellow colour and is a solid at room temperature, but an individual particle of gold, so an atom of gold, isn't yellow and isn't a solid. It can only have these properties when it is with other gold particles. So give yourself a score out of 7 for that section. Right, so we can use a different model to help us understand about what the particle model is saying. So what we can do is we can use Lego as a model for different particles. So use of models in science is really, really important. We use them in lots of different ways. We use them to model electricity, we use them to model particles. So there are lots of different places where we use models, and one of the important things is that we understand what a model is showing us and what we can think the strengths of a model are, and then also to look at a model and think, well, that's not very good because of these particular reasons. So we can use Lego bricks as a model for particles. So if you want to pause video and go and grab yourself some Lego, you can have a go at this yourself. If not, there's some slides to help with this as we go through. So what we can do is, and you can have a go at this now, as I say, if you've got your Lego, you can use toy bricks to build a model, and that can demonstrate individual particles working together to make a larger substance. And then what we can do is we can break down that large substance into the individual particles that make it up. So the key thing that you need to remember is that different coloured bricks will represent particles of different substances. So there are some questions on the worksheet that you can have a look at, but I'm just going to talk us through the model as well, just in case you haven't got any Lego at home. So what we have here is we've got some different Lego bricks, and here we can see we've got individual Lego bricks over here on the right side. So these would represent, these are red particles. Perhaps these could be oxygen or something like that. And then we've taken those oxygen particles and we've joined them together to make a bigger substance. So one of the things that we can obviously think about is that one of the strengths of this model is it allows us to join these substances together and put them together in this particular way. So here we have some different colours. So we've got 5 different colours, I was going to say 4 there, of particles. So we've got our yellow ones, we've got our lighter green ones, we've got our darker green ones, or maybe they're not 2 different greens, sorry, I'm colourblind, so the picture I'm struggling with a little bit here, and we've got the red ones. Key thing is that we've got different coloured particles in making it up, and so remember, different coloured particles are different substances. So therefore, when we take these individual ones and join them together, what we're able to do is we're able to make up a substance which is different from the one before, because it's got different things that are joined together within it. So potentially we could talk about this being a compound, whereas over on this right hand side we could consider this being a mixture because the particles aren't joined together. So again, there's a strength of this model in that it allows us to consider both mixtures and compounds from joining together different particles or not joining them together, as the case may be. Now, of course, the great thing about these particles is that we can join them together in lots and lots of different ways in order to make very complex substances. So you can take Lego bricks and build a Lego Death Star, but in exactly the same way we can take individual particles and build an incredibly complex thing out of it, like you, because at the end of the day you are made up of particles. So I would like you to pause the video now and have a go at the questions on the worksheet. The extension questions are quite difficult, so if you struggle too much with those, don't worry. So pause the video now, have a go at that worksheet. Right, so we're going to work through the questions now. So what's represented by an individual brick? It's of course a particle of a substance. Bricks have different colours and sizes. So we don't have any different sizes in our pictures, but you may well have had in Lego bricks that you had picked up. So different colours are particles of different materials, and different sizes because different particles can have different sizes. When we've got the bricks all connected together, suggest what it may represent. Well, that would be a solid. We could also say that it's a pure substance because it's got particles of the same type. We might even want to use the term element in order to describe it. So then we've got the idea that we've got grey bricks being hydrogen and black bricks being oxygen. So how would we model it? So we would want to join together grey and black bricks. If you want to be really specific, then we'd need to join together 2 grey bricks with 1 black brick, and that would be an oxygen molecule. So this time we've got black being oxygen and white being carbon, so therefore carbon dioxide. So carbon dioxide would be black bricks joined to white bricks, and if we want to be really specific, we'd have 2 white bricks joined to 1 black brick. So thinking about the extension, one of the things that you might think about is a patchwork quilt as a model of as a different model in which we can join together, because we have different patches that are joined together to make a much bigger blanket or a quilt. So we've said about the patchwork quilt. We could also use a necklace in thinking about modelling it, so they might be some different ways of modelling substances, lots of different ones that you could have come up with. But thinking about some strengths and weaknesses, so specifically thinking about necklace, we can see about how the individual parts join together, so that's a strength, but a weakness would be that, well, a link in a necklace is very similar to a link in the overall necklace, as it looks the same, and so its properties don't particularly change when it joins together. So that would be one way. It would also be quite hard with a necklace in order to actually model a mixture as well. Right, so final task is to have a go at this gap fill, either on the worksheet or you can do it in your books. So all materials are made up of tiny particles. There are many different types of particles. These particles come together in different ways to form different substances. These particles themselves do not share the properties of the materials they make, and we can use models to describe particles. Right, thank you very much. I hope that's been useful, and enjoy the rest of your day and the rest of the week, and I will catch up with you next week. Bye bye.